So now we're going to take a look at actually running a simulation. So the focus of this video is not really the simulation, but we're going to go over it quickly, and I just want to show you how user-friendly Houdini is now. With each release of Houdini, it just gets easier and easier to do your work. So if I press tab here and start typing bullet or ABD, you get this ABD bullet solver. Now this is a tool which encompasses everything you need to run a bullet simulation, right? You can even, when you see this little padlock there, you can see that there's a subnetwork in here with a load of other nodes, which has been configured for you by side effects, and it's a good way of learning how things are built. It can be a bit scary if you dive inside. You can see this has put us into the, what I was talking about, that folder structure. That's put us down a few layers there. So we were in the ball layer there. If I double click here, that puts me here where I can do some things related to the simulation, but don't worry about that. But we can explore through. Here we're in the dynamics. So this is where simulations actually happen. There's a whole load of nodes here, different code and different nodes. It's a good place to come and see how the people who actually built Houdini, how they put nodes together and how they build tools. And then we come out again here, and this is what we are going to be using. So this is how easy it is. I just drop this bullet solver, connect this up, press the visualizer there, and press play, and that's already simulating. Okay, this is the timeline at the bottom here, by the way. We didn't speak about that earlier, but you've got your standard play, stop, skip to the end. That's going to simulate, skip back to the start. Something useful whenever you're simulating is this kind of brain in the bottom here. This basically turns off or turns on simulations. So if I click that, you can see we get this off sign, and that means the simulation that's cached now because of this. You can see this blue line, so that's cached onto memory. But if I reset the simulation, turn this on, reset the simulation, turn this off again, I think it shouldn't actually play now, so that simulation has been stopped. Okay, so if you've got a really heavy simulation, then that's useful. So if I transform this up, so drop a transform, put this above here and raise it 5, and then give myself, come into this bullet solver. We're not going to go through everything here because it's larger than the scope of this lesson. We'll be coming back to that again in another lesson. And then just drop a ground plane, so that will give me something to collide with on the floor. Press play, and I have a simulation there, and that's working perfectly fine. It's accurate. If you want to, when it's something really simple like this, it's going to be playing really quickly, you can click on this real-time toggle, and that will limit the speed to 24 frames per second. So that's a good beginning. Let me drop I want to have a few balls dropping, okay? And one thing you could do is drop a load of transforms and just merge them all together. But that would take a bit of time. So a better way is to use something called the copy to points. Okay, so with copy to points, it's asking for geometry and target points. So we put our geometry here. I'm going to visualize that, connect that down there. And then here we need some points. So what has points? A box has points. Let's drop a box. Connect the box in here. So this will just take the points from this box. It will ignore the polygons and vertices, and then it will put one of these balls onto each of those points. And they're rotated because of the normals on the points. Okay. So that's a start, but that's not really what I want. So I'm going to give myself, change the size of this box, make this a bit bigger like that, and then quite a bit bigger. Okay, so I don't want the balls just kind of on the outside. I want them to be on the inside. So what I'm going to do now is use a volume. So, well, first let's drop a scatter, which is another very common node in Houdini. You'll be using this all the time. Press tab and scatter. And what this does is scatters points, gives you a quantity of points either over a surface like this. You can visualize that. It's running a bit slower now. because we've got a lot. And I've subdivided this. Whenever something like this happens, just press escape. Yeah, when that happens, just press escape on your keyboard. You know, that's a mistake I made. I've given, you know, we got 1,000 multiplied by how many points we got here, so it's going to run a bit slowly. One thing you can do is go here, set this to manual, and now I can make changes, and it shouldn't update in the viewport. So if I come here and then change this to 10, and now select auto update. There we go. So now we've got 10 points, but again, they're on the surface. I'm going to save this, by the way, since I, you know, almost crashed Houdini there. So, so that we get spheres kind of inside the box, we need a volume. And a way of making a volume is to use an ISO offset. Drop that, and you can see there's a change already. If I look at my scatter and give myself more points, they are now inside the box. So come to this scatter, I'm going to set this to just 15. Come to this ISO offset, we can visualize, you can see the volume there, and I'm going to, this uniform samplings, just push that up to the top, so that just gives me more definition. It's not too important in our case. And then we got this scatter, and now let's see our spheres. There we go. So that's something, and we can simulate that as well. Oop. So that's running a bit strange now. So what we need to do is come into the copy to points and just check this pack and instance. So you can see there something changed there in the geometry. We can't see the surface anymore. Now each piece of geometry here, each individual ball is represented by 1 point, and that's what Bullet needs. We won't go into that too much. We'll go into that again in the future, but that should mean that this simulates much quicker now and more, and kind of more what we would expect. So we're getting somewhere now. That's, we've got all the balls falling, but it's all a bit uniform. So we want to vary these points. So, their rotation and also some forces on the points as well. So a good way of doing that, and to have them different on each of these spheres. So on this side, we've just got the one ball. Here we got a point which represents each ball. And what we can do is put attributes on these points, which are different for each point, and those attributes will be copied onto each of those balls. So if I drop an attribute randomize, here you can see I just put AR, and I will look for words starting with A and then R, attribute randomize. I'm just going to put that in, leave it at default to show you that that is randomizing the color. So that will give me a different color on each point here. You can kind of see, can't see them there. If we press D on our keyboard with the mouse in the viewport, and first thing, if we go to background, set this to dark, that helps a bit. We can also go to geometry, point size, and make that bigger. There we go, we can see that a bit better. So each point now has a random color on it because of this, based on these values. So I can play around with this, and it should change them. But I don't want to randomize the color. I want to, first of all, randomize the orient. Okay, so that will change the orientation of the points, but it's not working yet. We need to change this to, so we won't get into it too much, but orient is not a vector, it's a quaternion, so it needs 4 dimensions to the value. If we come to the geometry spreadsheet, onto the points, we can see we got this orient, and we got a different value. We got 4 different values as opposed to a standard vector 3, which has 3 floats values. Here we got 4, and I'm going to change this to inside sphere, which will give me a more kind of random result. I think we could have left that at the defaults, but I typically use this inside sphere when I want things to be rotated randomly. So that's good. Let's take a look at the result of that. There we go, still a bit better. I realize I'm kind of going over a few of these things a bit quickly now, but we're going to be coming back to things like these things time and time again over the duration of this course. Okay, let's drop another attribute randomize. And what I want to do now is randomize something called V, which refers to the velocity. So that will change the speed of the initial speed of the objects here. So if we watch that, you can see just a little bit of change there. So we need to bump that up to give us some larger values. You can see there, so they're all kind of going off in the same direction there. So that again is because of the way that this is distributed. They're all kind of going towards positive, I think. So I don't want anything in X or Z. I just want them to be going differently up or down. There we go. And then lastly, I'm going to do one more, which is going to be, the name of the attribute is W, which is angular velocity, which is related to the spin of these points. Okay, so all of these attributes will be copied onto the geometry, and then that information feeds into the simulation after. So with the angular velocity, I think we need much smaller numbers. If I play this now, let me save it because I think the values would be too high and it's going to kind of explode. Well, not explode, but they're a bit over the top. But that kind of helps to show what that W attribute does. It gives you some spin, and you can see they're all spinning in different speeds and directions as well. So back to that W, let's drop this down to 0.1, 0.1, 0.1. We could have just set these to 1 and set this back to 1, but that's fine, it doesn't matter. But there we go. So what's kind of important to do with your nodes here is to note everything. So especially when we've got these three, so attribute randomize 1, 2, and 3, it's good to write down what we're doing. So here I'm going to write orient, here velocity, just so we can quickly, when you come back into your scene, velocity, and here W. Here we can just write V probably. So that's the name of the attribute. Okay, the rest of them, you know, here you can say move up, just so that you can see at a glance what you're doing. You know, holes you can see from the group that's being used, what we're doing. But it's a good idea just to kind of keep notes on what you're doing. So that's our simulation. Pretty much done, I believe. So if you remember, in this copy to points, we check this pack and instance. And now if we go into the geometry, you can see it's a bit different now. I can't kind of make any selection. And if I visualize the information here, it says we just got 15 points, which doesn't really make sense. If we come up here, we've got 47,666 points. So that's because they're packed. So each piece of geometry here is represented by one point, and that point contains information relating to the, you know, the transform and the rotation of this. So to be able to access this again, we need to unpack it. Okay, so if you ever find that the geometry is a bit weird, you can't access the polygons or the points, just drop an unpack, or you can use a convert, I think, as well. It should do the same job, more or less. Yeah, that will convert it to normal geometry. Okay, I'll just use my unpack there. And then again, drop a null with an out, and that's it.